Hello, welcome to another problem session. Um, Today we are going to talk about a problem that involves kinetic friction in a situation where the acceleration is constant. We so take a time to read the problem and see if you can solve it on your own, and then you can come back and look at my solution. Okay, so it's pretty standard problem. It says that it is sliding on this surface. Okay, it's not fixed to the ramp at any one place. It's from on the ramp, it goes from place to place. Okay, that's what I mean by sliding. So we're supposed to find coefficient of kinetic friction, that's mu sub k. So you're supposed to know the definition of that. Definition of mu sub k is magnitude of kinetic friction over magnitude of the normal. Okay, so that's the definition. We carry out the F equals ma for this, and we set it up because acceleration is not zero. We are going to go, you will get a sum of all the forces on box equals mass of the box times acceleration of box, right? So this will be the principle we'll apply. When we apply this principle, there are steps involved. First step is to identify all forces. Okay, so if we look at the box, gravity straight down in this direction. It's not in that direction, it's this down. So if you look at that direction, normal to this surface of the ramp, that's the direction in which there will be normal. The ramp will push on the box upward in that direction. That will be normal. Clearly you can see the normal and gravity not going to be equal. So many times major mistake, avoid Fn equals to mg. So this is can be true sometimes, but it's not always true. And so Fn is whatever the equation will tell us. Okay, whatever is required. This is a reaction force, so it will be as much as is needed. All right. In a particular situation, and that is dictated by the Newton's laws. Okay, so we identified two forces, and here is the this is the F equals 50 Newton, and then it's going up. The direction of motion is this way, which means the sliding friction will be, or kinetic friction will be that direction, Fk. So that's the 1, 2, 3, 4 forces here, and we have identified them. The next is to do a free body diagram. So it's always good to take another clear picture. This is the weight, this is the normal, and in free body diagram, all forces come out of a single point. So this looks like that way, so we can just do it that way. That's fk. And this one is horizontal. It looks like it's coming in, but we suppose draw coming out like that. So this is the F, and that's 50 Newton. Okay, let's see. The next step is make this into Fx. Sum of all the Fx equals mass Ax, and sum of Fy equals to mass Aay. So this is two equations we need to set it up, which means we need to think about x and y axis. Well, I'm going to think of this as x-axis and think of this as y-axis. And because of this angle, let's call this theta, then this actually is theta. If this is theta, then this is 90 minus theta, so this will be theta. So that's the theta. That's 30 degrees. That also means this is also theta. So we have angle of each of these vectors with respect to the axis we want. So it's very easy to figure out. Now x acceleration is all along this axis, and it's given, magnitude is given. So let's write down. So a x equation will be, let's start with any, let's call it this guy. So this will be f cosine, his projection is positive, so it's going to be 50 cosine 30 degrees. And then this is 0. This one has all x. So now I'm going to say mu sub k fn. I'm just going to write this as mu sub k fn. Then I go to this. This has, when I project on the x-axis, got a negative this, and it's the same amount of that. So sine, so minus mg sine 30 degrees equals to m times ax, and ax is all the a is entire a is along the ax, so just a. So this equation 1, we can write down numbers here. This will be 5, and this will be 50. Say g equals to 10 meter per second square. So you can see that this guy and this guy are all together. This, got the y. Start again with this. Project on the right. This is going to be negative projection because it's on the negative y-axis. It's going to be negative, and this theta is this way, so it's going to be opposite. So this will be sine part. So minus 50 sine 30 degrees, and this guy goes on the negative y also, so minus 50, this is the mg cosine 30 degrees this time. There's nothing here. Fn is, all of Fn in the positive y direction, and acceleration is that way, so the ay is 0, since ay is 0. So now these are two I need to solve, and I've solved it a little bit earlier, and I'll just go through it. So this is just 25. 50 sine 30 degrees is just 25, and 50 cosine 30 degrees is turns out to be 43.3. So this equation just turns out to be in the x direction 8.3 78 well, y equation is the first one to solve, and so minus 25 minus 43.3 plus fn equal to 0. So that's fn just turns out to be 3 and 5 is 8, and 2 and 4 is 6, 3 Newton. So this one is just that's 43.3, and this guy will be minus 25 minus 0.4. Actually mu k is unknown, and 68.3 is equal to 5 times 0.4 is that's equals to 2, and then we can simplify as so mu k is going to be, this is just 18.3, and so you bring this on the other side, bring to the other side, so 18.3 16.3 subtracts, and then 68.3. So you can plug in a calculator and get the. So I find that mu k is 0.24. Okay, so recap just before we go. So first thing was reading the problem and then identifying that we're going to use this principle, and then we had to follow these steps. And they were sufficient. When following these steps created sufficient information for us to actually carry out the calculation to the final answer. And this is a very standard practice in physics. When you read a problem, from problem, you want to be able to translate that into some principle you're going to use. That's going to be our strategy from now on. So whenever we read the problem, we're thinking exactly which principles of physics we are going to use. Okay, I hope that helps. See you in another video. Bye.